Hello, project people, and welcome back to a brand new episode of the Project Chatter podcast. Yep, you've guessed it. Val is absent again. I don't know where he is. Too much partying in Melbourne or Sydney or whatever he's doing that side of the world. But it's we've got Martin with us. How are you doing, Martin?
Yeah, good, thanks. Obviously in the wrong place if there's all the partying going on in Melbourne. But
Yeah, we're stuck here with snow in the UK, and I think we've just witnessed Brazil being knocked out. What do you think about that?
it's been brilliant. What a game. Getting ready for the big one tomorrow.
Yeah, I'm sure you are. I'm sure you are. But let's go to our guest, Dr. Alan Barnard. Hoe gaan dit, meneer?
Het gaan baie goed. Hi, Dale. Hi, Martin. It's great to be on your show and looking forward to the discussion.
Yeah, fantastic. That's the length of my Afrikaans, so we won't do the whole show in Afrikaans, but good to have a fellow expat on the call. Look, Val always loves to set the baseline for everyone, and I know there's plenty of people that do know who you are, plenty of people that do know a little bit perhaps about theory of constraints and what you've been putting out into the ether, if we will, and sharing your wisdom. But if you don't mind, just for the listeners that might be new to you, what is your origin story? How did you fall into the space? What's your career journey?
So I started off, I've just always been really curious about why good people make and often repeat bad decisions. When you look at what it takes to be successful in life, in any field that you pick, there's kind of four factors. Two of them are in our control and two out of our control. The things that are out of our control is good genes, having the kind of genes that allows you to tolerate a lot of pain and take a lot of risk can be extremely useful, also very dangerous, but very useful. And the second thing is having good luck. If you speak to anybody that's been really successful, that's the first thing that you learn from them is they realize how lucky they are, because small things can have a big impact, So just one decision can make the world of difference. Those are things that are out of your control. There's two things that are in your control. The first one is just hard work. Doesn't matter who you are, which field you pick, to become successful, you're going to work really, really hard. And that's why it's so important to pick something that you're really passionate about, because else there's no way that you'll ever tolerate the work that's required to become successful. But the fourth one is being able to make good decisions. And that was an area that I got really, really fascinated about. I started studying really successful people. I wanted to figure out which are those decisions that really, really matter a lot. And the ones that have become very successful, they often, have a track record of lots of failures. So it's not about whether they are, always really good at it, but I think they are able to take risks without being reckless. And I quickly realized that the key there is you have to make decisions where the option that you've selected has a big upside if it works and a small downside if it doesn't. I call those hell yes decisions, right? Big upside if it works, small downside if it doesn't. And then on the other side, stay the hell away from those hell no decisions, which is small upside if it works, big downside if it doesn't. So that's kind of I was always really curious about why good people make and often repeat bad decisions, and realized that, like most entrepreneurs, if I was successful in that, I could probably turn it into something that allows me to make a big impact in the world and hopefully to generate enough income to have a comfortable life. The other thing that's relevant maybe to my origin story is I've always been attracted by complexity. It's a character flaw, but if I had an option between simple and complex, I'd pick the complex. Between easy and difficult, I'd pick the difficult one, right? I love to challenge myself. And there's a quote that I read very early on in my career that had a massive impact on how I view the world, which is a quote by Jean-Baptiste Perrin, who's a very famous French physicist. And he said that the aim of all science is to substitute visible complexity for invisible simplicity. That's our job. Our job is to find that invisible simplicity, right? If you think about E equal to MC squared, right? it's mathematically a profoundly simple correlation between these three variables, right? But it explains so much visible complexity. It's incredible. And that sort of got me into this field. I started reading up, and I ended up reading The Goal, Dr. Eli Goldratt's classical book. I was very fortunate to meet him, you know, in my early 20s. I'd implemented, shortly after reading the book, I implemented in our theory of constraints in our company, got massive result. We doubled the throughput. We got our due date performance from about 30% to 100% all the time without spending any more money or making any major investment. And I was head of engineering and supply chain and IT, so I had a really big canvas that we could apply all these concepts to. But soon after meeting Dr. Goldratt, I realized that's going to be what I want to do with the rest of my life, is working with individuals and organizations, figuring out what are the avoidable decision mistakes that they make, coming up with hypotheses that we can go and test. And of course, project management fits right into that space, right? There's an incredible amount of visible complexity, right? Many, many parts, many interdependencies, lots of VUCA, right? A term that they use in the defense, lots of volatility, uncertainty, complexity, constraints, ambiguity of competing objectives. So to find that inherent but invisible simplicity, you know, that will allow you to do projects faster, to do more projects with less mistakes, with less cost and investment, that to me was just too compelling to ignore. And I was very lucky to have started working with Dr. Eli Goldratt already in the mid-1990s on some really, really big projects. So that's kind of a short origin story. My passion is all about decision-making, understanding why good people make and often repeat bad decisions, and using the insights that we gain from that to come up with new methods and apps to help them make better, faster decisions when it really matters.
Wow, that is absolutely fascinating. And yeah, you packed a lot into the short synopsis there of your career, but wow, so much to touch on, and already my mind's going all over the show. But if we stick with the baseline, theory of constraints. So those that have heard of it or those that haven't heard of it will go, well, it's a theory. So how do we apply it? But before we even go into that space, what is the theory of constraints? If you can perhaps try and explain it, and you probably can without a whiteboard, because I think it's probably easier sometimes explaining things with whiteboards. If those listening to this would go, Dr. Alan Barnard, what is the theory of constraints? What would you say?
So in science, we call something a theory if it's just a very simple but powerful explanation about why something is important and useful. Right? So if you hear theory of relativity, you'd expect somebody to tell you what is relativity and why is knowledge of relativity really useful and important. So the same with theory of constraints. So your first question should be, well, what is a constraint? Right? What is a definition of a constraint that could be very useful and important? And how is that knowledge useful and important when you're trying to analyze, manage, and improve complex systems? So that's the basic part. Second part is, okay, so why is it important and useful? And there's basically 5 decisions that practically you cannot accurately make without knowledge of a constraint in a system. So the first decision is, how do you decide on a goal? How do you decide on a target that you can commit to that's both ambitious but possible, if you didn't know what resource limited you from achieving that goal, right? So you start off by coming up with a financial target that says we want to double net profit. Well, the constraint could be one of 4 areas, right? You don't have enough demand to meet that target. If you don't, then guess what's the one thing to focus on? Figuring out a way to get enough demand, right? So, okay, now I have enough demand. Do you have enough capacity to reliably and profitably deliver that demand? No. Guess what's the one thing? That's the constraint. That's the weakest link. Focus on getting enough capacity, not by just adding, but first exploiting better what you've got first, and then if it's still not enough, then adding, right? The second or third type of constraint, so it could be the market, it could be capacity, it could be supply. Do you have enough supply of raw materials, of whatever inputs you need to produce enough to meet your financial commitment? If not, then that's the one thing. And lastly is, do you have enough cash? So the first decision about how do I set a realistic but ambitious target, I practically cannot do it without knowing what resource I don't have enough of. The common way of setting goals is, let's add 5% to last year's performance or 10%. But how do I know that I couldn't have achieved much more, or that's completely unrealistic unless I can overcome some kind of constraint? So that's the first main way that knowledge of a constraint is really important, helps us to set ambitious but realistic targets. The second one is how do I know where to focus my limited attention, my limited budget, if I didn't know where the weakest link is, right? If I didn't know what was the constraint. The third one is, how do I judge whether how a change will impact the whole system? And this is something that systems thinking and system approach were the first one to highlight, that says, if you're managing a system and you're making a change, following a holistic approach means that you can predict what the impact is on the whole system, right? Sounds very compelling and complete logical sense, but practically, how the hell do I do that if the system is made up of so many parts, right? The insight of theory of constraint says there's very few parts that actually govern the performance of the whole system. Sometimes only one, but very few. So if you think about a project environment, right? The big breakthrough that they had with critical path, why was critical path such a massive step forward? It said that you could have a project building an aircraft carrier, right? That has 100,000 tasks. I make a change. How do I know whether this change I'm planning to make, whether it's adding another resource or taking a resource away or changing the requirements, how will this small change impact the whole system? And basically it said that I only have to check the impact on the critical path. That could be like 100 tasks or maybe 200 tasks, right? So this dramatic reduction in complexity, in the same way that in production, you might have a bottleneck, one machine, that's the bottleneck that determines the throughput of the whole system. You can sell whatever you can produce. That's the only part I need to check what's the impact of a change on, to predict what the impact on the whole system will be. Does it strengthen the weakest link? Yes or no? If it does, then great. If it doesn't, then it has no impact. So the knowledge of the constraint gives me this ability. It's just like a hack, right? A shortcut that says the only thing I need to know about the system, and it could be made up of 2 parts or 2 million parts, it doesn't matter, is where's the constraint and how will the change that I'm thinking about impact this constraint or impact the critical path, right? If it's a project environment. So that's a profound simplicity that we've added. The fourth big decision is why a knowledge of a constraint is very, very important, is how do I know what rules to use to manage the system? So if you think about a project environment, we have rules for pipelining projects, right? We have rules for planning projects. We have rules for executing projects, like what tasks I will prioritize, etc. And we have rules for deciding when to make changes. If I don't know the constraint, I have no idea what the right rules are. There's a profound insight that theory of constraints brought forward that says the rules that benefit the constraint also benefits the whole system. That's the way to figure out what rules to use. Anything that's not benefiting the constraint, right, is local optimization. And that's a profound insight to tell us what rules to use. And then the fifth insight of why is knowledge of a constraint so important is, when should I change the rules? Only if a constraint moves. So if you want to create a stable system, have a single constraint that doesn't move, because then you can keep on using the same operating methodology. If you think about McDonald's, where do you think the constraint is for McDonald's? It's a number of customers walking into their restaurants wanting to buy their product. That's a thing that if they could get more of that, the company immediately does better, right? So they've designed their whole system to ensure that they don't waste that scarce resource. they don't want the constraint to move from that into the checking counter or to the grill or to the supply. And as long as they can keep those things to be enough to meet the demand, and they check it by looking at the queue that's forming in the restaurant, they can always use exactly the same methodology. So it's probably a little bit longer answer than what you hope for, but that's why it's called a theory, because it's a good explanation of why knowledge of a constraint is so important. And it's important for those 5 different reasons. Helps us to set realistic but very ambitious targets. It helps us to decide where to focus our limited attention and budget on. It helps us judge the impact of any change on the whole system. Helps us to figure out what rules to use and when to change the rules.
Wow. It wasn't longer. It was actually spot on. I mean, I was listening, soaking up every word you were saying there. And it's fascinating because what you said, you can absolutely apply to projects. I mean, you said it before, but just going through it in real time, I'm thinking the application of it. If you just simplify it down to those rules, as you say, we find ourselves in complex situations, right? But if we find the E equals MC squared, we can identify what it is we're actually looking for. And then those rule sets are interesting within itself, because often when we talk about resources on projects, we think either plant and machinery or human resources. But I think where we're going with this, and correct me if I'm wrong, there's other resources that we're thinking about as well. And one of the things that popped into my head was, I don't know, you might have come across it, tech planning. And I was thinking perhaps, is it almost a form of trying to simplify something quite complex to break down some of the, well, it is to break down those constraints, and tech planning in a way is to find a rhythm. And to the McDonald's example, I was thinking, well, if you're finding a really good rhythm for people coming through the door that is in total alignment with the cooker and the burgers and the counter and the till and everything, and people leaving as well, then that rhythm, that flow is really, really, really important, because the greater that flow, the more profit you're making ultimately to the bottom line. So I don't know, that's my layman's attempt at trying to dumb it down for myself at least, Alan. So yeah.
It's a great example. And if you think about, the contribution that theory of constraints and Goldratt has made on project management, right? One of the things is we're constantly looking for that inherent but invisible simplicity. So the breakthrough of critical path was profound, right? It says, where should I pay most of my attention on is on that critical path, because all the other paths have got some slack. So there's some buffer, right, that can be absorbed by unplanned changes and delays. But the critical path is really the most important. Einstein had a really, profound insight. He said you should make things as simple as possible, but not simpler, right? And sometimes we simplify it too much, right? So what did Goldratt do? He said, look, you generate a critical path. It's considered all the critical interdependencies, and it's shown you what's the longest interdependent path that will dictate the length of the project. But what does it ignore? It ignores resource contention. Now, this wasn't new to the inventors of the critical path method. If you go and look at the original paper that they wrote, they recognize that their method does not consider capacity constraints. And it wasn't an oversight. It was just that when you try to consider it, it creates a factorial problem. There are millions of ways of resolving resource contention when you're doing scheduling. It's a massive problem to solve. So they said, look, if you can put yourself in a situation where you have enough resources, you don't have to consider resources when you're building the schedule. It's a massive simplification. But guess what happens in reality? You don't have enough, right? And actually how you allocate the resources can make a huge difference.
Well, I was going to ask you about that. Sorry to jump in there, because when we talk about human resources, it's easy when it's plant and machinery. But when you talk about human resources, you have to bring in capability, experience,
Yes.
all those sort of they're almost intangible. And how do you make a judgment or assessment on how much of a constraint it is? Is there any sort of is there any equal E equals MC squared for that?
Yeah, so I think, first of all, going back to the definition, what is a constraint? Is that you have a goal, right? That goal, whether it's a project goal or company goal, right? That goal dictates the resources that you need. Do you agree?
Okay, yeah.
So change the goal, then it will change the resources that I need, right? So I have a goal to build an aircraft carrier, or I have a goal to deliver an IT project. Okay, now I from that I can decide what resources I need. But the goal, when I'm clarifying it in terms of not just what I want, but how much of it and when and for who, that tells me the demand that it will place on the resources. And any resource where the demand on that resource exceeds its capacity and capability is a constraint. Anything that I don't have enough of to meet that goal becomes a constraint. Where it's really difficult when it comes to human beings, like you said, is that the level of variability is dramatically higher than if the resource was a machine. And the question is, how the hell do I make a commitment? How do I even check if you are a constraint, if there's so much variability? And again, the simplification is like, which resources do I need to check? Only the ones where I feel like I might not have enough of, right? And practically, I can check that in execution by monitoring what the project is waiting for, what resources the project waiting for. Because it's really hard to quantify the capacity and capability and availability. All of those factors combined makes it almost an unsolvable problem. Like, how do I build that into my little project management system, right? Because I need to consider the capacity, the availability, the capability, the experience, the level of confidence, all of those things, right? Versus saying, look, if I'm starting execution, the only thing I'm tracking is the project waiting for a resource? So in a project environment, a bottleneck or a constrained resource is not the one that's the most loaded. That will take you off in a completely wrong direction. A bottleneck or constraint is the one that's causing most delays on the project.
Yeah, it makes sense.
Does it make sense? And that's a profound simplification. It says, as soon as I start, I'm just tracking, right? If a task is delayed, I simply ask the question, what is it waiting for? It's waiting for a structural engineer. Okay. When, there's enough of the evidence that it's now starting to impact, especially my critical path or critical chain, right? Okay, that's now a constraint. And then I follow the same process that I would follow for anything that's a constraint. The first step is, how am I wasting this resource, right? Like, okay, like Martin, you're the constraint, right? A lot of the project tasks are waiting for you. You're sitting in this project meeting for 3 hours to give us a 5-minute update. Like, why do you have to be here all the time? Can you phone in? Okay, that's going to give you back 2.5 hours, right? It's like, first look at where we're wasting that resource. Where are you overproducing? Where are you getting stuck waiting for other people? And then if it's still not enough, then go and add more. So that to me is like a practical thing, is how do I know I have a constrained resource in a project? It's not as simple as in a production environment where I simply do calculations to compare capacity versus demand. It's much, much more tricky in a project environment, but practically I can get fast feedback. Just start and see what is it waiting for.
Yeah. And comes back to what you said earlier around failure, right? Making those good decisions, and our failure is part of that as well. And that's quite interesting. I mean, we've spoken about before on the podcast around, fail fast, fail often, fail forward.
Yeah.
And learn from the failures as well. And that's the quickest way to learn often. But just coming back to it, that's the nicest thing anyone has ever said to Martin. So calling him a constraint. So thank you very much, Dr. Barnard.
He looks like a little bit of a bottleneck, and that's kind of another. It's another big change in mindset. You've probably seen that game shows like "You're the weakest link, goodbye." That's kind of, it's fear of constraints is the opposite. It's like, you're the weakest link. Hi, how can we help you? You're the most important dude on the planet at the moment, right?
Yeah.
And I think that's important. I want to just briefly touch base on something that you've mentioned about takt time and looking at it from, where's the bottleneck that's actually governing the pace at which we can execute projects, right? Because we have to consider that, else we're going to make unrealistic commitments. And we've been challenging ourselves and our clients to see what's the minimum level of detail that you need to plan a project to have control over the commitments that you make, so you feel like you're making a reliable commitment and that you can keep track of the project. And it turns out that in many environments, you just need three things, right? So we have a project that we're starting off and we have to create a plan for it, which is we need to know how long is it going to take, right? The first question is, we have probably some sense from the past that what is our scarcest resource, what generally causing most of the delays on a project. We say, let's keep on using Martin and say it's Martin, right? Or Martin's team. That's generally the constraint because it's an IT project. They both are responsible for fixing bugs and they have to develop this new fancy, functionality. So it's probably Martin or Martin's team. So, okay. So the first thing I need to know about this new project is how much of Martin or Martin's team's time will this take? And so come back, let Martin have a look at this project. We explain it to them and he comes back and says probably about 20 days. So, okay. Where does Martin sit in the flow of that project? Is he right at the beginning, right at the end, or somewhere in the middle? Let's say it's somewhere in the middle. The only thing I then need to know is to get all the stuff completed for Martin and his team to start working on it. How long on average would that take? And it turns out people are much better at estimating big chunks of work than breaking up into a lot of details and then adding up all the detailed estimates. You don't even know in which direction you're going to be wrong. But most of the time, it's like to get it ready for Martin and his team, probably about 2 months. Okay. Once Martin and his team has finished with it, how long to get the final deliverables done? Okay, another month. So now I have my schedule. So I can now use Martin and his team to say, okay, we have only one of Martin and his team, right? So we can only do one of these type of projects at a time. So I can now create that pipeline of projects. When should I start the project? By subtracting that 2 months. When can I commit to finish it? By adding that month on the end. And that turns out to be the least information I need to be able to actually create a pipeline of projects that considers our capacity and be able to track it. Because what I'm now tracking is, I want to track whether Martin and his team is ever starved of work. Because if they're starved, I should accelerate the release of new projects. Or if they start becoming completely overwhelmed, the backlog is growing, I should choke back the release of project and give them a bit of chance to catch up. So that's, again, it's a practical way. If I know the constraint, actually it requires much less detail from a planning perspective to make reliable commitments and to control the project flow.
Yeah, no, I'd agree with that. I mean, just with our theory of constraints, when you look at schedules and there's so many activities and they're broken down to the nth degree, there's this diminishing returns of granularity, right? And you're like, why make it more complex than it should be to make those key decisions? But just a couple of comments on what you're talking there, and I like the change of mindset towards a constraint, because it's something similar that we used to say with earned value management. Right? You challenge the greens and you support the reds, where most often it's the other way around. When you get into those exec, leadership meetings, they challenge the reds. You're like, well, no, hang on, support those. They're telling you there's trouble there, and then challenge the greens. Are those really all going smoothly? So just that mind shift switch, I think, is quite interesting, because I think a lot of people don't think that way on projects. And then it would be remiss of us, the listeners are probably going, why haven't you spoken about the topic yet? What are the common mistakes in managing projects that cause avoidable delays and cost overruns? So I wonder if we can sort of change gears slightly and focus on these common mistakes, because I'm sure people are dying to know, what are they? Are we doing them and we just don't know what they are?
Yeah, so I think it's useful to break them up into sort of planning mistakes. And those are, I call planning any decision that you make before you start the work is planning, right? Execution is any decision you make once you've started the work. And an improvement is any decision that you make after you've completed the work and you say, are we going to change anything, right? Are we going to change the way that we plan or the way that we execute? So from a planning perspective, by far the biggest mistake in planning, two big mistakes, is we ignore capacity when we make commitments. And as a result, we launch too many projects at the same time. And this is based on the fallacy where the sooner I start something, the sooner I finish it, right? And it's really easy to show that assumption is absolutely true if you're doing one thing. But if you do two or more things, that assumption is not true. It's the opposite. The later I start this, the sooner I finish. And just visually for the listeners or viewers out there, think about, you have just 3 tasks to do, A, B, and C, right? Each task lasts 10 days. So if they asked you, when are you going to have it done by, you'll say, A, I'll have done by 10 days, B, I'll have done by 20, C, I'll have done by 30, right? But now imagine launching all 3 projects at the same time, right? So you're starting to work on A, B, and C at the same time. So you do a bit of work, 1 day of work on A, then you switch to 1 day of work on B, then 1 day of work on C, you go back to A, B, C, right? You keep on doing that. Now check what happens. Even if there's 0 task switching cost, right? You instantly move from one project to the other. Think about the change in your commitments. If you were doing one project at a time, pipeline properly, you would have committed 10, 20, and 30 days on A, B, and C. And probably you would have said A is the most highest priority, so that's why we do it first, 10 days there, 20 days for the second one, 30 days for the second. If you try to do them all at once, what's your commitment going to be? It's going to be 28, 29, and 30 days. Does it make sense?
Yeah.
Now think about that, right? Project B, you're starting on day 2 and you now finish on day 28 or 29 actually, right? Whereas in the previous example, you would start it on day 11 and finish it on day 20. The later I started B, the earlier I finished B. And that's what's so counterintuitive. That's why we often make that mistake. So what we study in our lab is not just the mistake, but why conceptually people make this mistake, because it's so counterintuitive. Now, when you add switching costs to that, right, what you'll find is those 3 projects don't take you 30 days to complete. They often take you 60 days to complete. And there's something worse to it. Imagine I come to you, right, Dale, and I say to you, while you're busy with these 3, right, you task switching, I say, oh, there's a 4th one I want you to work on. What do you do now? You have no idea when you're going to deliver the 4th and by how much it will impact A, B, and C commitments, right? Whereas if we're doing just one project at a time, you would probably tell me, listen, I'll probably be able to start on day 31 and finish it at day 40.
Yeah.
Right? Very simple. So that's just one example, essentially for those listeners and viewers that are interested in what we've basically done is we've classified the mistakes that you can make in planning, execution, and improvement. We've also identified what are the assumptions behind those mistakes. It's not that people are ignorant or bad. is they have this common sense assumption, like the sooner I start, the sooner I finish. And as a result, they're using the wrong planning rule. Like the same with priorities. If you pick a mistake in execution, right? You have 2 or 3 tasks sitting in front of you. How do you decide which task to prioritize? There's a couple of ways that you could do that, right?
There's various ways I was thinking, yeah.
Yeah,
you
could
the
say, well,
yeah.
yeah, whichever one arrived first, I should prioritize that one, right? Or you could say, well, whichever is the shortest, I prioritize that one, or the easiest to do. There's a whole bunch of criteria. Now, imagine a lot of resources that are all sitting with a lot of tasks in front of them because we released too many projects, right? How important becomes it how each resource prioritizes? Because if they all are prioritizing in different ways, they will all be busy, but will never have enough parts to finish one project. We can do that in the simulation model and show you what happens if we allow people to randomly decide or to decide on local considerations. Compared to doing the following thing, I once was asked to do a project implementation in an aerospace company that was on the verge of bankruptcy, right? There was no money to implement any new IT system or anything. The first thing we did was he said, we have to make sure that everybody's prioritizing the same program and project. So we basically, on a daily basis, prepared these banners that we put inside of the workshop areas. And we said, if you ever have more than one task waiting for you, look up at the banner. The Saab project at the moment is the highest priority. Work on that one first. If you don't have any tasks for the Saab project, the next one is the Airbus project. And what you instantly do is you instantly align the priorities and things starts flowing. So that's another one is like, you know, we make mistakes when we prioritize. We allow people to use local considerations to prioritize rather than looking at what is the priority for the system and make sure that everybody's working on exactly the same priority, because that's how you get flow.
So if I can jump in there, because we controls folks, right? So we think about schedules and planning and, you know, Primavera and all that type of thing. Where do you sit with resource loaded schedules? Do the resources have to be in the schedules to drive those schedules, or can they be outside? If Val was on here, he said it before, in Australia, they don't resource load. He tries to drive it, and he says, well, because he's been in the UK, he knows what resource loading looks like, and he knows the benefits of it. But in Australia, the response is, we just don't do that. That's not how it's done. And he goes, well, maybe you should start thinking about doing it. Where do you sit with that?
I think the correct answer is it depends. If you can safely assume that you'll have enough resources, right, then you shouldn't consider it, because it makes the problem much, much more complicated if you have to consider them. Now, if you realize that there are many delays on the project because it's waiting for resources, then do I have to consider all the resources? No, only those that at least initially I feel is a bottleneck resource, you know, that based on past experience, projects were frequently waiting for them. Or if I just checked, you know, most likely with this project, what resource will we not have enough of? And they can tell me that. But even if I'm wrong in that initial assessment, like I said, if you just start tracking from day one, what is the project waiting for? You'll very quickly get feedback about what the real bottleneck is. And the real bottleneck is not the most loaded resource. The real bottleneck is the resource that's causing most delays on the project. I could have a resource that is only 20% loaded, right? It's causing most of the delays on the project because the demand on that resource all happens at the same time.
Yeah, Yeah, no, very, very interesting. And yeah, I like that critical resource planning rather than entire resource loading of schedules. But look, before we jump on to further ones beyond planning, which you're probably going to do anyway, I want to bring Machine Gun Martin in because, as you say, he's been sort of sitting there being the bottleneck. And I'm sure he's sort of started writing down plenty of questions to throw at you. So, Martin, over to you.
It's just like being back on projects again. So earlier in the pod, you mentioned the theory of constraints was developed in the 80s with Dr. Goldratt. I suppose my question is, what have been some of the learnings that you've mentioned in your research and in your dealings with businesses over that time? I know we've kind of mentioned some of the planning methodologies there. And maybe the basis of my question is the top 10 reasons for project failure hasn't really changed since the 80s. You know, maybe the order's changed a couple of times. We've had more technology in businesses, but what have been some of the learnings from when the original theory was developed to the present day?
So when I read the goal, I got hooked already in the forward, right? In the forward, Ellie codified the scientific method in the simplest form that I'd ever seen it before. He basically said, if you want to make advances in any field, you have to use the scientific method. But what is it? He said it's just 2 steps. Step 1 is have the courage to acknowledge inconsistencies between what you expect to see and what you actually see. And step 2, be willing, again, have the courage to challenge basic assumptions. So if there's an expectation gap between the target or potential and what exists, right, there could only be 2 bad assumptions that can explain that gap. The one is you've been unrealistic in setting an expectation, right? Or no, your expectation was correct, as the assumptions on which you've based your actions was wrong. So you were taking the opposite actions to what could have closed the gap, like the one I just said. Because you assume the sooner we start, the sooner we finish, we launch projects as soon as possible, we get stuck in a traffic jam, right? Stop, start all the time, multitasking, horrendous. So one of our biggest lessons was to say there's a massive inconsistency in project management. If you think about it, we've been doing a lot of work with the Defense Force, the Navy, right? From the 50s, when they were monitoring very carefully, gathering data of how long projects take and how often projects are late and over budget, do you think that that number has substantially improved over the last 50 years? No. How can it be? There's been massive advances in knowledge in project management, and there's been massive advances in technology that support decision-making within projects. How can it be? And our big realization was that when you are innovating and your innovation is only matching the growth and complexity and uncertainty, you'll only be able to maintain the current performance. You need a way of leapfrogging the increased complexity and uncertainty with your innovation. And there's 2 ways of doing that. The one is dramatically finding ways of simplifying, removing some of that avoidable complexity and uncertainty out of the schedules, right? Or having a way of, leapfrogging the innovation side. And that's something that we've been working on, is looking at both of those elements. I'll give you a simple example of both. Imagine you have 2 tasks and you're planning it, right? You've estimated 10 days for each task. So your project management system is going to deliver job cards that says task 1 starts on day 1 and finishes on day 10. Task 2 will start on day 11 and finish on day 20, right? That's your job cards. What happens if task 1 finishes on day 5? Right now, you want variability to balance out, right? You want the unders and overs to balance out, but you've just released a job card that says to task 2 start on day 11. So if you don't allow early starts in your project planning mechanism or in execution, you will never be able to benefit from early finishes. You'll be only penalized by late finishes. So if task 1 takes 15 days, task 2 is going to be automatically pushed out by 5 days. So the greater the level of detail you plan, the more you are harmed by this mechanism. Does it make sense? Compared to what if I just group those 2 tasks together and I say together they take 20 days and I let the second resource know as soon as resource 1 is almost complete, we'll let you know, be ready to start as soon as possible. So that's on the methodology side, right? Is understanding what's causing avoidable delays is if we don't allow early finishes to be capitalized on, either because of Parkinson's law, people will keep on working until the 10 days are over, even though they theoretically finished on 5 days, or because of the way that we issue job cards, the second task isn't ready and can't capitalize on that. You're always going to have projects that will finish late. Mathematically, as long as you have any overs, mathematically, it will finish late and over budget. It's not possible to finish early or under budget if you don't capitalize on early finishes, but you get penalized by late finishes. Does it make sense?
Yeah.
So that's on the methodology side. On the technology side, one of the areas that we've worked on in my research lab is, imagine having to make a commitment on a project when you know for a fact that it doesn't consider fully all the VUCA elements. It doesn't consider the variability in task durations, doesn't consider uncertainty of unplanned events, scope changes, doesn't consider properly all the complexities or the capacity constraints or the ambiguity. How confident would you feel to make a commitment, especially if many of your past commitments were late, right? Very low confidence, unless you're a novice or chronically optimistic, right? You're addicted to hopium. Now, imagine you had software that can actually consider that. And that's what we've been developing. It's a digital twin of project environment. So imagine reading in your full project plan or portfolio of project plans, and where you had, for every task, you had a planned duration of, say, 10 days or 20 days. You just get people like in an old PERT methodology to estimate best case and worst case. And now I can simulate the execution of that project, sampling between the best, likely, and worst case. And I can run thousands of replications. And I can come back and say, Dale, this is the range of outcomes you get under real life conditions. Now make a commitment. Now decide how much buffer you need and where to strategically place the buffer. Now have a look at where most of the avoidable delays are coming back. And that's what we can do today with our project portfolio digital twin, is you can actually read in a project plan of a single project or project plans of multiple programs made up of thousands of projects and sub-projects, but add in that element of variability or randomness and unplanned event, press the play button, see what's going to happen, and then test out what's the best rules to minimize the flow time, and as a result, minimize cost.
If we stick with the theme of technology, you mentioned digital twin. That was one of my notes I had before the pod. What's your views on AI and or machine learning, and will this help or hinder businesses in understanding some of those constraints that you've mentioned?
It's a great question. I think there's twofold. On the one, I'm super excited about the potential of it. At the same time, I'm massively concerned that the hype is way too high. For AI to learn, it needs a lot of data of repetitively the same thing.
Okay.
Right. So it's really massively beneficial to apply AI to production environments where we keep on making the same stuff. But projects are normally once off. Right. So unless I'm in an environment where I'm repairing F-19 fighters and there's types of projects that we often repeat, I can't expect AI to learn anything from past data. Where there is repetition, and there's enough repetition, because these machine learning algorithms needs a lot of data to learn to come up with good predictions, right? It's not going to be that useful. And that's, again, another very exciting match-up between digital twins and AI. If you think about a driverless car, right? You can use AI to learn what is the best practices for driving. But you're not going to put it into a driverless car and go, good luck, let's try it out, right? You're going to build a simulation model and stress test the hell out of those rules, right? Make little kids run in front of it, make, the sunshine on the traffic light so you can't properly read it, etc. To test if these rules actually work in real life environments. That's the scary part about AI, is there's no simple way of understanding the rule. It's not like a heuristic where you can explain it, where you can write an algorithm for it. Like, it's completely hidden. So the only time that you know whether the AI is really working is once you implement it. So that's where digital twins provide you with two benefits for AI. One, it can generate a lot of data. So I can pick one project structure and simulate it 1,000 times and generate data from that the AI can learn from. Of all the possible things that can go wrong, what are the avoidable versus unavoidable mistakes, etc. And then secondly, I can use my digital twin that if the AI did learn something that we think could be a better way of, say, planning projects than critical path or critical chain or agile, I can test it against these old rules and see if it actually performs better under real world conditions.
Yeah, wow. That's yeah, I completely understand. Yeah, there's so much potential with AI, but yeah, I kind of understand what you're saying around there's danger.
The hype is huge, and there's going to be people with a lot of egg on their face. I mean, we did a review recently with some customers that have invested quite significantly in AI and digital transformation, and the payback is around 15 cents per every dollar invested.
Wow. That's
not right.
No,
but they are doing it. Why? Because we are pressured to put in digital transformation, right? So be very selective where you're deploying your AI. A very exciting element that we're also working with one of our partners with on AI is any decision that's subjective, right? Which requires a lot of experience and intuition to make. What we've done is we've, with a partner, developed a platform that uses AI to learn how the top human experts make decisions.
Mm-hmm.
So if you think about asking a top expert, you give them a specific scope, you say, how long do you think this will take? How many resources do you think it will require? That's a very subjective decision, right? Yeah. Now, that person, if they've been doing it 20, 30 years, and I've seen many of these things, will tell you, listen, this is a kind of they won't tell you it's a 2.5 month project. They will say it's about a 1 month project or 3 month project, or they have classifications that over time took, they developed, right? AI would have to learn that. Here you benefit directly from that categorization or classification that the top expert took maybe 20 years to develop. And then you say, like, by the way, what do you need to know to tell me what would you commit to? And I say, actually, there's only 5 or 6 things. So there's another way that we can benefit from the bias that was developed by that top human expert by asking them directly, what do you need to know about this case to make your decision? Make a commitment or decide what's the best rule to use. So that's a very exciting area to me of using AI to learn how top human experts make decisions and being able to scale them and being able to offer their expert opinion as a second opinion to help novices develop that intuition faster.
Yeah, that's really interesting. It's quite a nice segue into my final question around a lot of the theory constraints. A lot of the stuff we talked about has been quite technical, quite theoretical, and maybe one of the challenges that some of our guests provide to us is really around soft skills and the importance of management, leadership, good communication. We had Colin D. Ellis on the other week around just the importance of that. And how do the two things interact? So, all the stuff we've spoken about so far, I've not heard much about good leadership in there. We talked about decisions, the process of making it, eliminating wastage, all that brilliant stuff. How do the two things combine in your view and your research?
There are many ways that you can sort of answer the question, but one way is to think about what's our constraint. What resource do we not have enough of to meet the demand that's placed on us? And the most obvious one is we have limited attention. The number of things that demand our attention will always exceed our available attention. So our attention, our limited attention, is our bottleneck, our constraint. And good leaders understand that and help people to not waste that limited attention, right? So normally the first thing that we do on the project is when we go in there, people are already overwhelmed. They're in chaos, right? They're multitasking like crazy. They feel completely out of control. They feel completely overwhelmed. So the first thing to do with the leadership team is to say, guess what step one is going to be? You're going to ask people, write down a list of all the things that's currently demanding your attention and tell us what you think you should stop doing. Right? And whatever is remaining on that list, what do you think the priority should be? And let's check it against the global priority. So that immediately will release attention, capacity that you can then deploy on the most important things. But there's two other areas that's also constraints, which is we often don't have enough of. The first one is trust. Right? So if you don't trust your team, if you don't trust the leadership, if you don't trust your customers, it's a massive issue. It causes massive amount of disharmony. So that's a sort of second soft skill that you need, is creating that safe space, making things very transparent where people can start rebuilding the trust. And then the last one is kind of willpower and energy, right? Is we never have enough of that, right? Because I mentioned it takes a lot of hard work to succeed in any environment. So again, great leaders are able to very quickly, tell people what they should focus on, right? What to stop doing, so that they have the capacity and bandwidth to focus on a few things that's important. Help to create those safe environments that help them to learn from experience and not, blaming each other, etc. And then helping them maintain that motivation and energy levels, right? And figuring out what it is, because it changes based on the team dynamics, right? And figuring out what is it that I can do to keep on encouraging it. And one thing that, I don't know if you've studied this idea of flow by Csikszentmihalyi, he identified this idea of when we in flow, right? It's when we are most productive, right? When we become completely unconscious of time and our senses. You get 2 hours done and sort of 2 weeks of work done in 2 hours because you got into that flow state of mind, right? So part of getting people motivated is learning how to get people in that flow state of mind. And that state of mind happens in a very narrow band. So if you think about a graph, if the vertical axis represents the complexity of the task and the horizontal axis represents the skill level, there's a very narrow band that goes up by about 45 degrees, which is called flow. That is where your skill level matches well the complexity of the task. Now, the task needs to be slightly more complex than your skill level to convince yourself that you have to give this thing your full attention, else you're going to mess it up, right? If it's too complex, right, compared to your skill level, you become overwhelmed. If it's too simple, you become bored and get distracted and watch cat videos, right? So that to me is the last soft skill of a good leader at any level in an organization, is that they're very well aware of that balance between matching the complexity of the task versus the skill level to keep their team in flow. And if they see them get overwhelmed, they can help remove some of that complexity. If they see them getting bored, they can add some complexity by, giving them more work, more complicated work, or maybe shortening the time that they have to get it done so that they don't end up being distracted.
Yeah, that is absolutely amazing. I love, it's remarkable the visuals that you're giving everyone just through talking, Alan. It's like, I can see it. I know you're on screen for me, but like I can see it as you're talking. And I'm obviously drawing it on my piece of paper as you're saying it, but it's really helpful. It comes back to what you said at the beginning of the pod, that E equals MC squared. Look, I know we're a little bit pressed for time. We're heading towards the end, but before Martin rudely interrupted us, we were talking about the common mistakes, and you started on planning. And I wonder if we could briefly just cover perhaps the rest of those common mistakes that those might need to consider.
Yeah, so in planning, if you think about the big decisions that you're making there is, how am I going to be releasing projects, right? So what mechanism will I use to control the release so I don't release too much too early or too little too late? That's a really important decision. If I think about how will I buffer my project, right? Do I buffer every task, or do I buffer the project and the feeding path? That's another really key decision. How I allocate my resources is a really big decision. For example, I have 5 projects and I have 5 engineers. Do I allocate 1 engineer per project? Or do I allocate all 5 engineers to the most critical project? Like, big decision can have a massive difference in terms of the time it takes me to execute that project. Those are all planning decisions. On the execution side, it's really about the prioritization. How do I prioritize tasks? When do I expedite? When do I escalate? Those are all really critical decisions, right? As to say, an issue is something that's blocking me from making progress. As soon as I get an issue, I'm being blocked to make progress on my highest priority task. I should immediately escalate it. I shouldn't wait for the project meeting, because I might be on a critical path and, I've lost 4 days because I'm waiting for a project meeting to arrive, right? So knowing whether I am or am not on a critical path or chain is really important, etc. On the improvement side, it's essentially, these are decisions that we make after we've done the work and we have to decide whether to make any changes, like, should I speed up the release or slow it down? That's an improvement decision. And like I said, as you could, for example, utilize, if we knew that Martin was the bottleneck, we're just monitoring how frequently Martin is being starved of work. If there's frequent occurrences that they're being starved, I can send a signal upstream to say we can start releasing a bit more projects or a bit more tasks into the system. If I find that Martin is never starved and are actually overwhelmed, there's a backlog that's building up, I can say, guys, slow down the release. So those are sort of improvement. The benefit of these digital twins that we've developed is we have a library of all of these best practices compared to traditional ways. So you can test waterfall against agile, against critical chain, run it on your project data and see which one will give you the best impact, etc. So, but I will, send you a little write-up in terms of what those decisions are, the conceptual mistakes that we make, and then what the principle and practice are to reduce or even prevent those mistakes.
Yeah, that'll be amazing. We'll add it to the show notes. And, I mean, an hour was never going to be enough to cover everything, so we'd love to have you back in the future. But just for those folks that don't know, you do have your own podcast. You put out a series as well on YouTube. Where can folks go and find you?
Yeah, so the simplest place is on YouTube. I have a YouTube channel under Dr. Alan Barnard, ALAN BARNARD. Our website where all the apps are visible that we've developed over the years are called harmonyapps.com. And my personal website is dralanbarnard.com, and our company website is goldenresearchlab.com. And you mentioned I have a podcast series. It's called Impossible Unless. And this is targeted on, the most limiting assumption or belief that we have is when we convince ourselves that something is impossible. And the profound inherent simplicity I found when I was researching this, going back to that quote, is like there's this invisible simplicity, is how do you get somebody to challenge an assumption or belief that something is impossible? Is you say to them, it's impossible unless. Now, just experience what your mind does, right? It's impossible to lose 20 pounds in 1 week unless. It's impossible to halve this project lead time unless. It forces your mind automatically to identify those conditions that, if you could put it in place, can make the impossible possible. And that's basically what I do with my podcast series. Is every episode we pick some target or goal that most people consider to be impossible, and we say it's impossible unless, and we share some of the unless conditions.
Yeah, I actually did listen to one or two, and yeah, I thought I actually, after listening to it, I actually use it in conversation. So I went, oh, that's really difficult. I was like, well, yeah, it's really difficult unless what can we do to make, so it's a really powerful thing. I think Martin used it the other way a couple of years ago, Alan. He said it's impossible to drink 500 different types of beers in a calendar year unless, and then he actually got to 600 and something, but that's a whole nother episode. But look, it's been fantastic.
It's also something that people can try, right? So one of the problems is how to get yourself to think out of the box, or your team, right? And one thing is if you give yourself or somebody else a target that they think is realistic, they will only call it realistic if they already knew how to do it. So one way is like take the target and either increase the magnitude or reduce the time or the cost budget, and say to you, do you still think it's realistic or possible? Yes, okay, do it again until everybody agrees it's impossible. Now it's impossible. You say, okay, it's impossible unless, and let them list those conditions.
That's awesome. And I'm sure folks are going to go and have a listen out for that. We'll post everything in the show notes as well. And yeah, please do send us across anything you do have. And like I say, we'd love to have you back to discuss more in any which way, shape and form. But before we let you go, we do have a feature that we'll take you through, and it's called Fiverr. And for that, I'll hand back to Machine Gun Martin.
Thanks, Dale. Yep. 5 quick fire questions all about yourself. So if you're ready, let's get going.
Yes.
Okay. Number 1, what's your one piece of advice for people new to the project management profession?
Is use every opportunity to learn from experience, right? Try to identify what are avoidable versus unavoidable mistakes and focus on the avoidable mistakes.
Brilliant. Number 2, biggest misconception about the theory of constraints?
That it's all about debottlenecking. When you debottleneck systems, you create systems that are balanced in capacities, and that creates chaos. So you actually need to identify one constraint and make sure upstream and downstream it has enough capacity to keep the constraint in the same place.
Nice one. Are good leaders born or made?
I think it's a combination. I think, it's going back to the genes. Some people have the genes that just naturally do it. That doesn't mean that anybody can't improve on those skills, but some people will always just be exceptional because they just have the genes.
Sure. Other than your own, what would be your book recommendation to our listeners?
There's a couple that I would, for those that haven't read Critical Chain, in that space, I would highly recommend reading Critical Chain. But there are books in terms of very different sections that I love reading, like a recent one that I read called No Bad Parts, right? Which is essentially talking about our personalities, that the old fallacy that we have a single mind, a single personality is complete rubbish, right? Else we would never be conflicted. We have many parts, and we create new parts often to deal with new situations. Now, what happens if you find a bad part, that part that causes you to lose your temper, to react and throw a tantrum or to be jealous or whatever, as if you try to get rid of it, right, it will defend itself. Right? It will tell you all the reasons why it's fully justified to do that. So the idea there is to treat it like a caring parent. You say, let's have a discussion with you. Like, what do you think your job is? Right? Okay. Yeah. It's to protect you. Okay, do you think that what you're doing now is protecting me? No, it's not, right? It's causing the opposite. And I think that same concept is so true for managing complex systems, that every part there has a role to play. You can't say you're the weakest link, goodbye. You're the bad part, goodbye. Is have that discussion and make sure that they clear how they should be contributing. Make sure they understand how sometimes their actions are causing harm, and make sure that the measurements and incentives are aligned to get them to always do what's best for the system and for them.
Brilliant. Wow, what an answer. And then finally, if you had your time again, would you go straight into academia or something different?
Wow, that's a hard question to ask. I had a coaching call this morning. It's like, how do you know that you're living the best life, that you're doing the best that you can, you know?
Deep.
It's a very, very hard question to answer. So all that we have is our intuition, you know? Are you feeling like, you know, there's this huge gap? And I think generically where we make the mistake, I do it all the time, right? There's a gap between our potential and our actual performance, in both the impact that we're making on the world and the income that we can earn. And the mistake that we make is we keep on reading more books, we go to masterminds, we get coaches, you know, and all that does is it increases the potential, which makes us more and more depressed and anxious, right? Versus saying, we probably already have enough potential. Let's focus on how the hell do we get our actual performance up. And the best place there to start is, what can we stop doing?
Wow. Awesome advice there, Dr. Alan Barnard. It's been amazing. I've learned so much. I'm going to have to go back and re-listen, because there's so, you know, often we talk about the episodes, we say, you know, we'll get the nuggets for you, we'll go down rabbit holes, but every single, not just going down into the rabbit hole, has, you know, the journey down the rabbit hole, there've been nuggets along the way. So thank you so much for sharing. You've been very generous in sharing as well. So really appreciate that. Before we let you go, any final thoughts you want to leave our listeners with?
No, just thank you. I mean, the questions were brilliant. You know, the answers is only as good as the questions, you know. So thank you so much for that, and the amazing job that you guys are doing in getting this knowledge out there, especially to people that are new to project management. You know, going back to that first quote, there's so much visible complexity. You know, it's so easy to be overwhelmed. It takes a lot of courage to say there must be inherent simplicity, a few simple things that we can do immediately that can dramatically improve our project performance and dramatically increase our confidence in our own ability. And I want to just keep on encouraging you guys to do that and help people see what that invisible but inherent simplicity is.
Brilliant. Thank you so much. Martin, anything you want to add?
I can't do anything better than that. How about yourself, Dale?
No, just like I said, I thoroughly enjoyed this. I will be listening to your podcast, Dr. Alan Barnard, and keep tuned in. We'll stay in touch. We'll get you back if there's anything in the future you'd love to come and share with our project community as well. But yeah, thank you for all that you do as well to improve the lives of others. Like I say, that's it, folks. That's all we have time for. We do. We absolutely have your contact details. We won't, for GDPR reasons, we won't share it on this podcast, but we've got them. And we'll stay in touch. As we say, folks, this is the end of this podcast. But remember, before you go, please do help us pay it forward by sharing a link to this episode on your favorite social media. Once again, a massive baie dankie, a huge thank you to Dr. Alan Barnard. And thank you all for listening. Till next time, we say stay safe, be disruptive, and have fun doing it. From me and Martin, it's bye for now.